Part B. The manager also conducts a significance test for bowling alley revenue and fish consumption per person. He produces the computer output shown below for the analysis of bowling alley revenue versus fish consumption per person. Okay, so this isn't anything our calculator can do, but this would be what it would look like if you had a computer package that you had all your numbers in columns and you just said, right, run this test. So you've got to be able to interpret the answer, okay? A lot of this is not helpful, okay? You don't know what the T equals means, you don't know what the DF equals means, and you're not supposed to know that. But this bit, that's the bit you're meant to be looking at. Pick out, you know that phrase p-value, okay? The p-value is the thing that is going to tell you what's going on here. Comment on the correlation between bowling alley revenue and fish consumption per person and what the board of directors should do in light of the manager's findings in Part A and Part B. I mean, this is a very strange question, to be fair, but they do occasionally do this little bit at the end of a correlation question. So you do need to sort of know how to tackle this. Your p-value is very low, and in fact that p-value is less than your 1%. Okay, so remember that your p-value is the probability of falling under the critical sort of boundary. In other words, if you do that, you reject H0. So it's the probability of rejecting H0, but whilst using, H0, which is assuming it's true. So this idea of like a type 1 error, basically. So your p-value is the probability that you would reject H0 while it's still true. If your p-value is very small, then you should be rejecting H0. And, it's up to us to determine what very small, in inverted commas, means. But generally, that's what we're doing with any hypothesis test. If our p-value works out small, we reject H0. So in this case, our p-value has worked out very small, so we should be rejecting H0, which is that there isn't correlation, okay? And we should then be concluding that there is correlation between our bowling alley revenue and our fish consumption, okay? Does it say anything where it's positive, or is it a two-tailed? I don't think there's anything that tells us, oh yeah, not equal to. Okay, so that's like a two-tailed test, okay? So our correlation, we can say that the test shows that there is correlation between the bowling alley revenue and our fish consumption. Because the p-value is less than 0.01. Because remember, we were doing a 1% test on the other one. Let's stick with the 1% here, but it's definitely less than 1%. Okay, that's fine. That's actually 2 of the 3 marks. What is the correlation, if any, and how do we know it? Okay. What should the board of directors do in light of the manager's findings? So the manager has found that there is negative correlation between margarine consumption and bowling alley revenue. He's found that there's some sort of correlation between bowling alley revenue and fish consumption per person. What should the board of directors do? Absolutely nothing, okay? Because these are absolutely ridiculous things to compare, Okay, don't start thinking, oh, do I need to write something about, oh, the bowling alley should serve more fish and less margarine or something like that. They don't want you to say that. They want you to realise that these quantities are ridiculous to try and compare, and to just say, well, yeah, you can compare two quantities, but if they're not actually connected, you might show that there's some sort of like numerical correlation between them, but actually in real life, in reality, there is absolutely zero, to connect them at all, right? And it's just like a fluke of the data that it looks like you've shown there's a correlation between something. There's nothing you can really do to act on these findings. So basically, the board of directors should do nothing because these quantities whilst being numerically correlated are not relevant.